So I'm really pleased to be here this evening, and I don't think I've ever had the opportunity to talk to this many young women at one time. So that for me is a real treat, and yeah. And I have only 10 minutes, and I've asked Michelle to
The clock
warn
is
me
going.
if I go over. And I have to explain to you a little bit about what I do, what I've been doing in terms of building telescopes, and also a little bit I'd like to tell you how I got to do what I do, which I feel very privileged to do. All in 10 minutes, the universe. So bear with me if I talk a little fast, and there'll be time in the questions. But I think one thing that I did want to say is that when I started in this field, or before I started, when I wanted to go into this field, my grandmother essentially said to me, "What are you doing? You are never going to find a husband. You're going to be in your books all your time, all the time. Why would you ever want to do what you do?" And when I was in high school, I had a number of jobs. I worked in a library, I worked in medical records, I worked selling encyclopedias, you name it. I had to earn money to go to university. And all I know is that I spent most of my time looking at the clock. And it would be 9:03, and an hour later I would look up and it'd be 9:06. And an hour later it'd be 9:17, and I was bored to death. And I don't ever experience that feeling in what I do. I love what I do. And I also am concerned when I give talks like this, and especially to younger people in the audience, people will look at me and say, "Oh my goodness, look what she does, I could never do that." Well, if I had watched me when I was in high school, I would have said, "Oh my God, I could never do that." So don't look at me now, look at me then. And I had no clue that I could do what I do now, or that I could study science, or that I would even be good at it. I had no clue. So just keep that in mind. What do I do now? Let's see.
You have to point it that
Yep,
way because
oops.
the computer.
Point that way. I'm an observational astronomer. That means that I use telescopes with very large mirrors to look at the universe. And I look at the universe. You're going to hear from Vicki, who listens to the universe. And I think we decided, Angela, last night, you touch the universe. You feel the universe.
Smell, maybe?
Smell the universe. We all approach this in different ways. And what I'm showing here, you can see the band of our Milky Way galaxy. And I know a lot of you don't think about the universe every day, so let me just give you a quick, you are here kind of view. Here's our solar system. There are 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And poor little Pluto up there got demoted a few years ago, you may remember. It's no longer a planet. And if you just want some perspective, relative sizes, that's the Earth relative to the limb of the sun. It's tiny. And our solar system, our sun, about which 8 planets revolve, is located about 2/3 of the way out in a disk. This is our Milky Way galaxy. It's made up of about 100 billion stars, not unlike our own sun. We're about 2/3 of the way out in this flattened disk, and this is as if we're looking edge on, if we could step outside the Milky Way and look back. And just for perspective, the sun and the Earth are separated by a distance such that it takes light, which travels at 186,000 miles per second, takes 8 minutes for the light from the sun to reach us on Earth. Milky Way is one of about 100 billion galaxies. So I said there are 100 billion stars in the Milky Way. There are about 100 billion galaxies, not unlike our own Milky Way. And those turn out to be, in astronomical terms, the nearby galaxies. This nearby galaxy is called Large Magellanic Cloud, is about 150,000 light years away from us. This is about 2 million light years away, the Andromeda Galaxy. And if we look at the faintest smudges, and this is one of the deepest images ever taken by the Hubble Space Telescope, they may be something like 12 billion light years away. So when we say astronomical, we mean it. So a large part of my career has been spent using the Hubble Space Telescope. This is a telescope that is in orbit about the Earth, about 600 kilometers up. orbits the Earth every 90 minutes or so. This is Edwin Hubble, after whom the Space Telescope is named, and he's the person who discovered the existence of other galaxies, and not only the existence of other galaxies, but the fact that the universe is not a static place. The universe is actually undergoing a tremendous expansion. So how do we do that? This is my part of the detective story. We have to devise a way to measure how far away galaxies are. And I'm happy to answer questions about this, but I can give whole lectures on it, and I can't do it in my 8 minutes. But essentially the idea is we create a ladder out into the universe. We measure the properties of stars within galaxies, and that provides a unique measure of how far away the galaxies are. That then allows us to determine, since the universe is expanding today, we can extrapolate backwards as if we're running a movie backwards and see how long it's been expanding for. And that gives us the age and the size of the universe. So that's what I spent a great deal of my career doing. We've also learned in recent years that not only is the universe expanding, it's also speeding up in its acceleration. And so the universe turns out to be, we don't know what most of the universe is made up of. There's a form of energy that's causing the universe to speed up. There's a form of matter, which Angela will tell you more about, the dark matter. And the way that we learn these things is because all we have available to study astronomical objects is the light that's coming from these distant objects. So we can't go into a laboratory, as Michelle said. We can't measure the distances. We can't measure how bright things are. We can't measure the masses. We have to devise a way to use light that's coming from the distant universe. And the bigger the bucket, essentially, the bigger the size of the mirror that we use, the more that we can study distant objects, and also the greater resolution or clarity, the bigger the mirror. So for the last 12 years, I've been involved and led a project to build what will be the largest telescope in existence, optical telescopes, called the Giant Magellan Telescope. And this is a telescope that will be located in the Andes Mountains in Chile. It's made up of 7 mirrors here, and the total diameter of the telescope will be 80 feet. It will be, well, let me move on to the science, because I know I'm going to run out of time. Why do we want to build this telescope? One of the things that we'll be able to do is study the earliest light in the universe. So we know that stars form, galaxies form like the Milky Way. Here's how we casually toss the mirrors in, by the way, once we throw them into the telescope. So we will be able to witness for the first time those faint blobs that I showed you in the deepest image ever taken. We'll be able to see in detail how those galaxies were forming and merging. By the way, we don't observe in the daytime.
Just artists do.
Just artists do, that's right. And I won't go into detail. I'm happy to answer questions about these lasers that are firing. It's not a Star Wars gimmick. We actually do use these. And this telescope now, we've just improved the construction. We're starting to build the telescope in Chile. We've already cast 4 of the 7 mirrors that will be in the telescope. And we're hoping to be on the air in 2021. And the whole telescope will be completed in 2025.
1 minute.
Okay. 20 million times the sensitivity of the human eye. If we could look at a dime here in Chicago using this telescope, if there were a dime you were holding in Detroit, we could actually read what's on that dime. And if you'll allow me the fact that there's no oxygen on the moon, if we lit a candle, if there was oxygen, we could see that candle on the moon. So as I said, we could look at the first light in the universe. One of the other areas we're very excited about is the possibility of finding life on other planets, orbiting other stars in our Milky Way galaxy. And this telescope will be the first telescope that will have the capability of doing that if it's there. I'm really proud having come to the University of Chicago. Chicago is a partner in this telescope. There are 10 partners. It's an international project. And I'm going to end with the words of John Steinbeck. I think sometimes we think of the universe as a distant place, but as he said, man is related inextricably to all reality, known and unknowable, plankton, a shimmering phosphorescence on the sea, and the spinning planets in an expanding universe, all bound together by the elastic string of time. So I'm going to end there. Thank you very much.